Negations of quantified statements. Last time we spoke about quantifiers. So what does negating a statement with quantifiers mean? So for example, we have a statement, something like this. For all integers x over 5 is a rational number. What is the negation of this statement? Well, the negation of that statement is there is an integer x, but x over 5 is not a rational number. So if we were to use our symbolic logic, so P of x is a statement about x. In this case, x over 5 is said to be an element of the set of rational numbers. This one, how do you read this? This is a quantifier plus a statement about x. Okay, so we are assuming x to be an integer. So this one is read something like, for all x, or for all integer x over 5 is a rational number. This is in symbolic logic form. If we were to write that in our math sentence form, for all integer x over 5 is a rational number. Okay, so let us negate that, but we shall use symbolic logic. Okay, so this is our symbol for negation. We are negating a statement with a universal quantifier. That is equivalent to there is an x such that P of x is not true. Okay, so that one is not. Again, the negation of our statement with a universal quantifier is there is an x such that P of x is not true. So if we were to write that in math sentence, there is an... Okay, so this one is our original statement. The statement with a universal quantifier. Its negation now is there is an integer x where x over 5 is not a rational number. Another one. For all real numbers x squared is greater than or equal to 0. So, let this be our statement about x squared is greater than or equal to 0. In symbolic logic form, this one can be written in this way. For all x, or for all x, let's say for example, real number of x, P of x, or P of x is true. So in math sentence form, for all or for any real number x squared is greater than or equal to 0. How do you negate this statement? This statement is an assertion about all real number x, and it is saying that x squared is greater than or equal to 0. Well, what is the negation of that? You know, there is a real number x, but x squared is not greater than or equal to 0, which means x squared is less than 0. So in symbolic logic form, the negation of our statement with a universal quantifier is there is an x where P of x is not true. The original statement is saying for all x, P of x is true. But its negation is there is an x where P of x is not true. So let us write that in math sentence. This is the original proposition or assertion. For all real number x squared is greater than or equal to 0. Its negation is, okay, I'm sorry. Let's go back. Its negation is there is a real number x, but x squared is less than 0. Okay, so I will show you a table, and this will show you the negation of statements, and these are written in universal quantifiers and in existential quantifier. So what is the negation of this? All x are y? Well, there is an x that is not y, or some x are not y. Our statement, no x are y, another universal quantifier, a statement with a universal quantifier. What is the negation of that? some x are y. There is an x that is y. When you say there is an x, there is at least one x that is y. This is a statement with an existential quantifier, some x are not y. Its negation, all x are y. How about this one? Some x are y. Its negation, no x are y. Or all x are not y. Okay, so let us put that into action. So let's say, for example, our proposition is, or our statement about x is 2x minus 1 is divisible by 2. And our x here is an integer. Okay? X is an integer. And 2x minus 1 is divisible by 2. Okay, so for all x, for all integer x, p of x is true, or 2x minus 1 is divisible by 2. Its negation, how do we read its negation? There is an integer x, but p of x is not true, or 2x minus 1 is not divisible by 2. For all x, 2x minus 1 is not divisible by 2. Okay, what then is its negation? Let us read it. There is an integer x, where 2x minus 1 is divisible by 2. There is an integer x such that 2x minus 1 is not divisible by 2. Its negation, for all integer x, 2x minus 1 is divisible by 2. There is an integer x such that 2x minus 1 is divisible by 2. Its negation, for all x, for all integer x, 2x minus 1 is not divisible by 2.